Technology that's good for the environment, like batteries that store clean energy or catalytic converters that reduce car pollution, they can take their own toll on the environment. They rely on metals that need to be mined, some right here in Minnesota. But what if the type of metal they used didn't really matter anymore? A research group at the University of Minnesota is making that future a reality. It's invented a process that can make any metal act like a precious metal. And here to tell us more about it is Paul Dauenhauer. He's a MacArthur Fellow and professor at the University of Minnesota. He led the team that did research into this. Thanks for joining us.
Happy to be here.
So, in the simplest terms possible for the non chemist like myself, and I imagine most of our listeners, explain what your team has invented.
Well, we work on a technology called a catalyst, and most people have heard of this technology from the use in their car. And what it does is it controls reactions to make them do what we want. In your car, the emissions that come out are things like NOx or hydrocarbons or carbon monoxide, and they flow through a catalytic converter, and that forces them to react to things that are not a problem, like nitrogen in the air or CO2. I mean, that's a problem, but it's much better than carbon monoxide. The challenge, of course, is these catalysts are made up of all sorts of different materials, and the properties of their performance depend on that particular metal.
So tell us then what this process that you have invented, would it make it possible to recycle metal, use any metal, and then limit the need for mining, for example?
So we have some metals that are very precious, like platinum or palladium or rhodium. And there are other metals that we have abundantly around us every day, and we can just recycle and use. Think of something like an aluminum. An aluminum can is so
Yeah.
ubiquitous. Well, electronically, they're very different. So we found a very clever, well, we think is clever way to add or
Mhm.
remove electrons to different metals to make them take on the properties of other metals and give them the performance that we want.
And I understand that device is called the catalytic condenser. If I were to come to you and to your lab, what does this look like? How big is it? How does it work?
It's about the size of a postage stamp, and it looks like a little computer chip.
Oh.
The actual base of it is silicon, low grade silicon, very inexpensive. And then on top of that, we use special technologies at the university for fabricating individual layers of atoms.
And I assume you have taken maybe, for example, aluminum, and have you had it behave like palladium or rhodium or platinum or one of the precious metals?
So right now, what we've taken is aluminum, and we've taken its oxide form and shown that we can put electrons and take electrons out of that material. And not only can we change it, but we can really push it a lot to the point where it takes on the properties of an entirely new material. Now, that was the proof of concept that this was actually possible. And what we're doing now, of course, is we're expanding our research into whole entire other areas of other metals and other applications.
And what response have you gotten since publishing your findings from academic colleagues, or even the automotive industry or electronics industry?
I've been contacted across the board from other academics. At the same time, I've had people contact me that are interested in the technology. Can they purchase these devices? Well, not yet, because we have to commercialize them and manufacture them. But that's we've also been contacted by people who want to be part of that commercialization process.
And so, what's next?
We at the university are going to continue the basic research that lets us figure out how to do this in the absolute optimal way, the best technology, the lowest price, and the most efficient. But in parallel, the goal is to find the best strategic route to commercialize the technology and be able to make it a product where it can actually have environmental impact.
Professor Paul Dauenhauer at the University of Minnesota. He's also a MacArthur Fellow, and he led the research team into the work they're doing with catalytic condensers. Thanks so much for talking about your work. I appreciate it.
Great to be here.